The steps for the practice problems in the back of the substitution method for solving systems of equations. All right. Now, before we get started, I'm going to outline a few important rules of the game for algebra so that we remember not to fall into certain traps. So, rule 1 of the game. These are, I'll just title this Rules for Algebra. Okay. So step 1, or pardon me, rule 1 is that 3x plus 5 is not the same thing as 8x. This means does not equal. These are not like terms, and that's why they can't be added. So these are not like terms. So in a situation where you have 3x and you're going to add 5, we just have to write 3x plus 5. All right. However, 3x plus 5x is 8x. Okay, so that's the first rule of the game. We're going to try to make sure we don't fall into that trap of adding these guys together when they're not like terms. All right. Step 2, or pardon me, rule number 2. We always remove a value by performing the opposite operation. So, for example, here's some basic examples. If you have x plus 4, and that's equal to 10, then we are going to take away 4 from both sides. And that has the function of canceling out a positive 4 with this negative 4. That's just going to leave x on the left, and we'll have 10 minus 4 on the right. And since neither of them have an x, we can subtract them like normal, and we get x is 6. If we have an m minus 10, and that's equal to whatever, 2, we're going to do the opposite operation, which is adding 10 to both sides. And that has the effect of canceling out negative 10 with this positive 10. So now we've isolated an m. That equals 12. All right. If we have, say, a 5x equals 15, we have to recognize the opposite operation is a hidden multiplication. So this really is shorthand for 5 times x is equal to 15. So to do the opposite operation there, we are going to divide by 5. We will divide by 5. And that has the effect of undoing a multiplication by 5, dividing by 5. So then I get x on the left and 15 over 5 on the right, or 3. And lastly, if I have a situation maybe with a fraction, like a third of x is 10, well, I want to do the opposite of multiplying by a third. So I could divide by a third, or if I want, I could multiply by the denominator, because this 1 is being divided by 3, so I'm going to multiply by 3. I would multiply by 3, and that is the effect of canceling out these 3's. And then we get 1x is 30, or x is 30. Okay, so those are our 4 situations. We have an adding situation, we have a minus situation, we have a divide situation, and we have a times situation, and we have a divide situation. Okay. Now, the last rule of the game is the dinner plate rule. We're going to start with the values furthest away from our variable. So if we have a situation like 6x plus 2y minus 3 equals 0, and I want to, say, isolate y, for example. Okay. Well, if I want to get y by itself, right, I eventually want something that'll be y equals blank, 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 blank. Okay. To do that, we have to start with the things that are further away from y, and we'll slowly get to the 2. So the rule 3 is always remove terms that are further away from your variable, which is an x or y, first. So we'll start with those. So that means if I've got 6x plus 2y minus 3 is equal to 0, I've got 3 things that I need to remove. I need to remove a 6x, I need to remove the 2, and I need to remove the negative 3. So which one should I do first? Well, the 6x maybe is the furthest one away, so I'll do that one first. And remembering that we're looking at this y, the negative 3 is further away than the 2, so we'll do that one next. And lastly, we'll do number 2 here. So let's just take a look at what that looks like. Step 1 is we're going to remove 6x by subtracting 6x. So we have 6x plus 2y minus 3 equals 0. We're going to subtract 6x. Subtract 6x. It cancels this out, and we get 2y minus 3 on the left, and 0 take away 6x on the right, which is just negative 6x. Step 2 is we are going to do the opposite of taking away 3. So we are going to add 3 to both sides. Giving us 2y is equal to, and then we have the situation where we have negative 6x plus 3. So does that take us to negative 3x? No, for the reason above. 3x plus 5, or any number with a variable, can't be added to just a regular number. So that means we just have to write it like normal. And then we divide by 2 to get rid of this 2. So then we will divide both sides by 2. We divide each term by that 2. That cancels out the 2's, and we get y is equal to negative 6 over 2, x plus 3 over 2. Okay, so those are our rules to start. So now we'll keep those rules out to one side as we work through our problems. All right, so now let's start on question 1. And I'm going to keep these rules out right behind here like that. All right. Okay, so question 1. I've got x equals 3y minus 10 and 3x plus 8y plus 13 equals 0. Now, I think we have to first decide what's step 1. We're going to isolate a variable, right? Now, which variable is easiest to isolate? Well, it looks like this variable has already been isolated. So we'll just write that step out here. So we've got x equals 3y minus 10, and x is already isolated. That's nice. It means we don't have to do that much work. All right, so then we move straight on to step 2, which is we are going to substitute that in. So that means we're going to rewrite this expression, the other equation, 3, and we're going to place this 3y minus 10 inside the set of brackets. So I'll write it in the same color, 3y minus 10. And then we have to keep writing the rest of the line. And we have to be very careful to make sure we keep all the positive and negatives exactly the same. Plus 8y plus 13 equals 0. Okay. Now, it's important to have done this on the other equation. So we can't plug this back into itself. We have to plug it into the other equation. All right. So step 3 is we're going to solve. So we're going to isolate y. So the first thing we end up doing, like maybe we can think of it as step A, was we're going to expand. So I'm actually going to rewrite this whole expression. 3 times 3y minus 10 plus 8y plus 13 equals 0. And I'm going to multiply this 3 back in. So 3 goes into both of these guys here. And then I get 3 times 3y, which is 9y. And I get 3 times negative 10, which is negative 30. And I'll write the rest of the expression like so. Plus 13 equals 0. Okay. So that's part A, as we expand. Part B is we are going to group like terms. So that means x's with x's, y with y, and constants with constants. Okay. So if I look here, it looks like we have some like terms. We have a 9y and an 8y. They're going to group together. And we have a negative 30 and a positive 13. Okay, so I'm going to get 9 plus 8. And if I wasn't sure, I would put that in the calculator. And I get 17. So we get 17y. And negative 30 plus 13. Negative 30 plus 13 is negative 17. Minus 17. I'm going to still write the rest of the line. We have an equals 0 here. Okay. Now, we have to isolate y. Now, can we add these together to get 1y or 0 y's? No. We have to remember, these types of expressions are not like terms, so we cannot group these guys. These are not groupable. And then we're going to, part C is we'll do our adding or subtracting, our further term. So we'll deal with the adding and subtracting first. Okay. So I've got 17y minus 17 equals 0. So we'll get rid of the subtracting here. We're going to do that by doing the opposite step. We are going to add 17 to both sides. Adding 17 to both sides. That's the opposite operation. Okay. And that helps us get rid of our negative 17. And it leaves us a 17y on the left equal to 0 plus 17, or 17 on the right. Okay, and our last step is we are going to do our multiplication and division. We're going to remove those terms. So we've got this 17y, and let's remember, that is code for 17 times y equals 17. Every time we have an expression with a number next to a letter or a letter next to a letter, that's a hidden multiplication every single time. It's never going to be anything different. All right, so that means to do the opposite, again, we divide by 17, and we divide by 17. And that cancels out our 17s here to leave a y equal to, if I wasn't sure what 17 divided by 17 is, well, it's 1. Okay, getting there. All right. Now we're going to do step 4. We did step 3, which was solve for a variable. Now step 4, we are going to back substitute. So that means we're going to take this y is equal to 1, and we're going to plug it back in to the isolated equation from before. So we're going to use the equation from step 1, which is x equals 3y minus 10. So we're going to say, put that in for x is equal to 3y minus 10. And so we're going to replace the y with a 1. 3 times 1 minus 10. And we have to, again, remember the hidden multiplication here between the 3 and the y. That's multiplying. And so that means 3 times 1, not 3 plus 1. Okay. So that means we have 3 times 1, which is 3 minus 10, because x is equal to negative 7. Those are our two answers. X is negative 7, y is 1. And then we're done. All right, so we're going to try to repeat these steps for question 2. I am not going to label what the steps are in this case. For the next one, I'm actually just going to write step 1, step 2, step 3, step 4. Okay, so for number 2, we've got y is equal to 1/2 of x minus 6, and we have x plus 4y minus 12 equals 0. All right, step 1, isolate a variable. I said I wouldn't do that anymore. It looks like this one is already isolated, so we have a y isolated already. So that's the variable we're going to isolate, which is to say we're not going to do any isolating. Okay, we get to move straight on to step 2. So step 2 is we are going to substitute. So I'm going to take that value and we're going to plug it in to this equation. So instead of a y, we're going to write x plus 4. We have to write every single part of this equation except for the y, because we said the y is equal to this thing. So I'm going to replace this with 1/2 of x minus 6 minus 12 equals 0. Okay. And then step 3 is we'll expand, and we'll solve. So the first thing to do is part A is expand. So we're going to expand 4, multiply it by 1/2. 4 times 1/2. Well, we write everything else the same. And 4 times negative 6. So x, and then I have 4 times 1/2. If I wasn't sure how big 4 times 1/2 is, I could say 4 times 1/2 in the calculator using the fraction button here. A and B over C equals, the answer is 2. Plus 2, but it's 2x. And 4 times negative 6 is going to be negative 24. And that's minus 12 equal to 0. All right, now step B is we're going to group any like terms. So our like terms are x and 2x. And I'll use a different color for the negative 24 and negative 12. So x plus 2x is going to be, well, that's actually code for 1x. So that's 1x plus another 2x's. That'll give us 3x's in total. So we get 3x. And negative 24 minus 12. Negative 24, take away 12. It's going to give us negative 36. Minus 36 is equal to 0. Step C, we're going to deal with all the adding and subtracting first. We're going to get everything away from the side of x. We're going to start with the thing that's being subtracted. So we're going to add 36. We're going to add 36. That cancels out the 36's. This is the opposite of subtracting 36. And then I get 3x equals 36. And then, last step, we're going to do any divisions. So we're going to divide by 3. So remember, this is a hidden multiplication, 3 times x. So we're going to divide by 3 to get it away. And that tells us that x is equal to 36 divided by 3. 36 divided by 3. And that gives us 12. And then lastly, step 4. This is going to be back substituted into this equation. So I'm going to rewrite the line of the equation, y equals 1/2. But instead of x, I'm going to replace it with the value 12 minus 6. And then I'll multiply 1/2. Oh, so we got to remember that's a 1/2 times 12. And so I'm going to simplify that expression. It's going to be y is equal to 1/2 times 12. And again, we have this fraction button we need. 1/2 times 12. That's actually 6. Half of 12, you can imagine, being 6, minus another 6. And then we find that y is 0. Okay, so those are our two solutions. X equals 12, y is 0. Okay. Moving on to step 3. So I'm going to write down both these equations first. So I'm looking, as I'm writing, for easy variables to isolate, and it doesn't look like these guys are very easy because they have coefficients, numbers in front of the variables. Coefficients is what they're called. But I think we'll isolate the x. So for step 1, we're going to isolate x. In this expression. So the x plus y minus 11 is equal to 0. We're going to get x by itself. So we'll start with all the things that are not being multiplied. So or added or subtracted. So we'll do the opposite of taking away 11. So we'll add 11 to both sides. And right now I'm using the rule that I'm going to start by removing terms that are further away from the variable. So 11, or the negative 11, was the furthest value away from my variable. So that's the value that I started with. Okay. So rewriting the whole line, we get x plus y now is equal to 0 plus 11, which is 11. And then we're going to get rid of this y. So this is the last thing to get rid of. So we'll subtract y from both sides. And so now we've got to remember, when you have 11, you take away y. We've got to remember you cannot group like terms. That's our rule of the game number 1. Not allowed. So our y's on the left cancel out, leaving us with an x is equal to, and then we have just 11 minus y. It doesn't simplify. They're not like terms. Okay, so that's great. I'm going to put that in a big double bracket green box so I can refer to it later. All right. So step 2 is we are going to substitute this value into the other equation. It always has to be the other equation. We can never substitute it back in. If we do, we end up getting something like, in this case, we would be told that 0 is equal to 0, which is true but not helpful to us. So we're going to plug this into this equation. So 4, and instead of x, I'm going to write 11 minus y. 11 minus y. Minus 5y minus 8 equal to 0. Move on to step 3, which is we're going to solve for y. So step 1 is we're going to expand a 4 into a set of brackets. 4 times 11 is 44. 4 times negative y is negative 4y minus 5y minus 8 equals 0. So these guys became these guys. Then we are going to group any like terms. So we have a 4 and a negative 8. Pardon me, 44 and negative 8. That's one set of like terms. And negative 4y and negative 5y are also like terms. 44 minus 8 gives us 36, and negative 4y, take away 5 more y's. Well, we already are at negative 4y. So we take away, so let's plug that in, negative 4, and we're going to take away 5, and we find we get negative 9. So it's going to be negative 9y is equal to 0. All right, so we start with the thing furthest away from y. And this is the thing that's being added or subtracted to the y term. Now, we need to make sure that we cancel out this term on the left. So it means we subtract 36 from each side of the equation. That's going to get rid of the 36. Now, you might say there's no addition here of 36. But that's true, but this was a positive 36. And so what we're really doing is doing the opposite of the symbol in front of the value, which is a positive number. It cancels it out. And it gives us negative 9y is equal to 0, take away 36, which is going to be negative 36. And then next we're going to deal with the multiplication and division. We have to remember that this really says negative 9 times y, or I won't write an x here, that's confusing. We'll do negative 9 times y is equal to negative 36. That's what this really means. So to do the opposite, we are going to divide by negative 9 on both sides of the equation. That gives us a y on the left, and negative 36 over negative 9 is 4. But if you weren't sure, you could just grab a calculator. Negative 9 divided by negative 36 divided by negative 9 is positive 4. The two negatives cancel out, and we have 36 over 9, which gives us 4. And step 4 is we back substitute. So we're going to plug this back into this equation we put into a big box before. So the reason I put it in the double bracket green box is so we find it easy to find later. And I think it was easy to find later. So I'm going to rewrite this line. X equals 11 minus, but instead of y. So that means that x is equal to 11 take away 4, which is 7. So then we have x is 7, y is 4. Okay. So last one, we have 6x minus y plus 10 is equal to 0, and 3x plus 2y is equal to 0. All right. So what are we going to isolate here? So let's look and see. It looks like we've got some coefficients here and here and here. I think this is the easiest to isolate because it doesn't have a coefficient. In fact, it kind of does. It has a -1 coefficient. But that might be a little easier to work with than others. All right, so we'll start with this equation for step 1. 6x minus 1y plus 10 equals 0. Notice I wrote the -1y in, because I don't want to forget that -y means -1y. There's a coefficient there of -1. All right, so we're going to isolate y. So we'll get the things furthest away from y away from the side. So what's furthest away from y? I think this 6x is. And remember, when we have this, these guys are multiplied together, so they come as a package. If we're doing subtracting, we have to subtract both of them. That's going to subtract 6x from both sides of the equation. And so that, now, be very careful here. That does not give us y plus 10 on the left, although we might want it to. We have to remember there's a -1 here. So it's a -1y plus 10. And that's equal to 0, take away 6x. It's going to be -6x. Now the next thing we're going to do is we're going to get rid of this 10. So we're going to take away 10. Take away 10. And we get -1y on the left is equal to, so you might think maybe it's -16x. But we have to remember, some things are not like terms. So when something has an x and something else doesn't, or something has a y and something else doesn't, or something has an x and something has a y, we cannot group them together. It's only if they have the same variable that they can be grouped together. So that means these guys cannot be added, so we have to just write them in a row, -10. Now, there's two things we can do here. This says -1 times y is equal to -6 minus 10. We could do one of two things. Option 1 is we could take this expression and we could just divide both sides by -1. It has the effect of canceling out the -1, and that's fine. -6 divided by -1 is -6 divided by, nope, that's wrong. -6 divided by -1 is going to be positive 6x. -10 divided by -1 is going to be equal to positive 10. So we get positive 10 here. And there we go, we've isolated y. I'm going to put a big box around that. Okay. Fine, so step 2 is we're going to plug that into the other equation. So I'm going to rewrite that line. 3x plus 2, but instead of the y, I'm going to replace this whole thing with y, because it's equal to y, and it says 6x plus 10. That's all equal to 0. And so, oh yeah, right. And then we do step 3, which we're going to solve. And to do that, we're going to expand this 2 into a set of brackets to open it up, get everything out playing. 2 times 6 is 12 x's. 2 times 10 is 20. It's all equal to 0. It's our expand step. B is we are going to group like terms. Looks like there's an x and a 12x here, but nothing for the 20 to group with. That's fine. So we'll just group the x's. We got 15x plus 20. It's equal to 0. Step 3 is we're going to deal with any adding and subtracting. First, we're going to take away this 20 from both sides of the equation. So we will take away 20, take away 20. That has the effect of canceling out these 20s. And so then we get 15x on the left and 0 minus 20, or negative 20, on the right. Last thing to do is to deal with this 15. So we're going to divide both sides by 15. Divide by 15, divide by 15. Negative 4 over 3. All right, so if we weren't sure how to simplify that fraction, I divided the top and bottom by 5 to give us a simplified fraction of 4/3. However, if I wanted to, I could just divide them with my calculator. Negative 20 divided by 15. And it gives me some long decimal. But if I press my fraction button now, it turns it into a fraction. But it's kind of a weird looking fraction. What the calculator is really trying to say right here is negative 1 and 1/3, which is a mixed number. And usually when we've been dealing with these sorts of questions, we'll usually write an improper number just because it's a little easier for us to do math with. So we can multiply 3 times 1 and add 1. So we could say negative 3 times 1 is 4, or plus 1 is 4. And we have the denominator on the bottom, 4/3. That's improper. And if I want my calculator to turn something into improper, I look at the very top of my fraction button, and I can see above the second function of this button says D over C, a higher letter over a lower letter, just like an improper fraction is a higher number over a lower number. So if I use the shift button, or maybe your button says second, 2ND, shift, and then I press the fraction button, it's going to toggle back to say negative 4/3. Negative 4/3. All right. Now we have to back substitute. So we have to go to step 4. We're going to take that value and plug it back in to our isolated equation. So we're going to take that equation. Y is equal to 6. This is in green brackets, by the way. And instead of x, we're going to write negative 4/3 times negative 4/3. And we've got to keep writing this whole expression, plus 10. And we're going to try to evaluate that. So it gives us y is equal to 6 times negative 4 over 3. 6 times negative 4 over 3. It's negative 8. Okay. And if I take negative 8 and I add 10, I get 2. So y is 2. Okay. So our values are x is negative 4/3 and y is 2. So make sure to email me if you have any questions about any of these steps. And good luck studying. And we'll see you on Monday.